Wherever the shooter points the dot is where the bullet is going. Of course, assuming it's zeroed. It's simple, it's sealed, and it's nearly indestructible. When it comes to the reticle, one MOA covers roughly 1 inch at 100 yards and scales from there. For example, a 6 MOA dot covers 6 inches of target at 100 yards, 12 at 200. Smaller dots in the 2 to 3 MOA range leave more target visible for precise work at distance. Larger dots in the 6 to 8 MOA range are faster to acquire. But for precise aiming, the 1 MOA is always the go-to, so it doesn't block the target. As far as the mounting goes, the most popular ones are the ones with the aimpoint footprint, and the red dot industry just love to copy this proven design, and many aftermarket mounts work with them too. Most of these optics have roughly 12 inch-pound torque screw spec, so they can mount tight on the mount, and the mount stays tight on the pick rail to withstand recoil, or drop. And it can do all that to retain a good zero. As far as the power source goes, you can leave it on for a long time, and most of them today can run past 50,000 hours, and when you pick it up from the safe, the dot is already on. Experienced users, however, always recommend changing the battery every year anyway, just to top it off. But the one trade-off is that it only limits the engagement distance at 1 power. But that problem has been a thing of the past, because putting a magnifier scope behind the red dot can now extend the optic's range. Open reflex sight. This one doesn't have a tube. It's just a low-profile housing with a large exposed front lens that mirrors the reticle on it from this tiny emitter window. It basically works the same way as the tube-style red dot. These are very popular to go on handguns or use them as a backup offset optic on long guns, such as the Trijicon RMR, Holosun 507, Delta Point, and a bunch of copycats you see on the market. Some are good and some are total trash. There are many footprints on the market, but the most common ones are the RMR and RMSC. RMR is basically for a full-size gun, and RMSC is for a subcompact. But they can also go on different mounts to go on long guns. Not all mounts are high quality, which is why the market has introduced different mounting plates with higher tolerance screws and fit, such as the Aimpoint Acro mount that clamps the optic on the slide instead of just relying on 2 countersunk screws. Some mounting plates also have additional recoil lugs and recoil fences to completely wedge the optic to provide more support so they don't tilt or shift. When it comes to shooting on the draw, the dot appears faster with minimal view obstruction depending on the shape of the optic. Some of them also offer different dot sizes, such as 3 or 6 MOA. Different sizes cover up the target differently, and generally speaking, a bigger dot also appears slightly more crisp, and the dot's edge appears rounder than a tiny dot, especially when the brightness is cranked up for people with astigmatic vision. And that applies for all types of red dot sights on the market. Speaking of astigmatism, many people struggle with red dot sights because the reticle appears smeared or starburst. Some people blame the optic's quality, but most likely it's the person's poor vision. I would say this is the biggest cons of a reflex sight, and besides that, another con is the exposed body, because things can fall into the optic blocking the emitter, like water, rain, and mud. Closed emitter optic. These became popular in recent years, and the idea was to seal the LED and optics inside that hardened optic body, so nothing can get in. The overall operation of the sight works the same way as an open reflex, basically the same footprints and same everything. However, if rain and snow can still be a pain in the butt to wipe off the screen, and if you smear it, it just distorts the red dot projection, and you literally can't aim with it. But overall, it keeps debris out of the internals quite well. Shake-awake optics. Shake-awake technology basically works by turning off the red dot if it's in idle, for example. Once the optic detects motion, such as you picking it up, the dot will appear. It can extend an already 50,000 hour long battery life to maybe 100,000 hours. The overall operation of the optic remains the same. It's just a new technology added to make the battery last longer. Some like on the Holosun AEMS, it also contains an onboard capacitor to store the battery juice to keep the optic on even if the battery is removed. However, if it's in a carry optic, it will always remain on if it's inside a moving vehicle or being carried inside a holster. Auto brightness. One of the biggest problems with red dot sights, even with the top product, is brightness control. Auto brightness technology gathers ambient light sources around the optic to adjust the reticle when transitioning between environments, which creates a real problem moving from bright sunlight into a dark structure mid-operation. However, it only gathers light sources around the optic, not based on where it is aiming. For example, if the target plane is either too dark or too bright, the optic has no idea how to optimize the dot brightness. The latest Trijicon RM RHD has introduced a front-facing sensor that will do exactly that, so the dot brightness doesn't get washed out. For example, if the gun is aiming at a target with a weapon light shining the light back at you, it will adjust the brightness accordingly. But currently, this technology still has a bit of lag. Prism sight. Remember earlier we talked about astigmatism is the biggest problem that a red dot user has to deal with? Well, Prism sight doesn't have that problem because inside the housing, a roof prism erects the image, and an LED illuminates an etched glass reticle from behind. That etched reticle stays visible in daylight even with a dead battery, and it allows BDC marks and mil-dot grids no direct LED emitter can replicate. For example, the Trijicon ACOG is a fixed 4x magnification prism sight that you see on many active-duty US service rifles. However, there are also 3.5 power magnification scopes with better eye relief distance adjusted for soldiers wearing helmets. For shooters with astigmatism, it's the only type on this list that delivers a clean, crisp image instead of a starburst. For infantry, the BDC holdovers extend effective range without adding electronics to the loadout. The trade-offs are fixed eye relief, which slows close-range acquisition under stress, and BDC marks calibrated to specific loads, which drift when the ammunition changes. Holographic sight. Holographic sight and reflex sight look similar, but they differ based on reticle projection and power usage. A holosight uses a laser diode that folds a beam through mirrors and a holographic diffraction grating, projecting a reticle encoded inside the window itself at roughly 200 meters. The standard EOTech ring and dot appears in space rather than sitting on glass, which minimizes parallax at combat distances and lets the eye stay on target even slightly off-center. The large outer ring is the fastest acquisition geometry on this list, and it can also be used to gauge target distance based on an average height of a human-sized target. But the trade-offs are significant when it comes to the battery life. Laser diodes consume more power than LED, so the battery life runs 600 to 1,000 hours against 50,000 for a tube collimator. And some EOTech models have night vision mode to make passive aiming under night vision nods possible. Now you know the basics of sighting technologies available. If you're interested, be sure to watch this one next.